Hello, hello. Good afternoon. It's Junichiro Horikawa. Let me know if you can hear my voice. I think I'm hearing an echo. Okay, how's this? Okay. So, this is Junichiro Horikawa, and this is a tutorial live for Houdini, which is called as Houdini Algorithmic Live. And today I am going to show you how you could create a setup for Vellum in order to bend the input mesh using a curve. And there is a difference between the one that I did previously, which was a while back ago. So I did a similar tutorial before, which is called as freeform curved folding, which was numbering 103. For this one, it's pretty similar. It looks similar, but there's a big difference. And what's different is that in this freeform curve folding, you had to recreate the mesh of your input with your curve so that you can have a clean, hard edge on a mesh. So by using an input curve, you have to do a lot of heavy work in order to modify your mesh geometry in order to achieve this. But then for this one that I'm going to show you today, you don't really need to cut or modify your mesh at all based on your input curve, but you just need to calculate the bending angle based on the curve information for each bending constraints for Vellum. And that's all you need to do in order to achieve the bending simulations like this one. The downside is that you don't get a clean edge, but the benefit of using this one is that you could have a smooth like folding on a specific area by controlling the threshold, like how much you want to affect the bending and what's the angle for each positions. For example, if I increase the threshold for this one, you could have more smooth. Let me also decrease the angle. You could have more smooth edge bending. Okay, so production wise, I'm not sure what this setup could be used for, but it's a pretty simple setup. You just need to calculate the angle based on a curve, or it could also even be a vector field or any kind of vector related value. So I think there is a lot of possibility to use the method for a lot of cases. So that's what I wanted to share today. Okay. So let's do this from scratch, shall we? The key point is that you don't really need to remesh the input geometry, but you just need to have your curve and calculate the angle for each constraint. And each constraint for the bending is attached to the pair of two triangles. So each pair of triangles has one constraint. So for each constraint, by setting a correct angle, you'll be able to do a bending simulations based on underneath vector value. Okay, so the idea itself I think is pretty interesting, so hopefully you'll also find it interesting as well. Let me know if you have any questions or anything, and hello everybody, thanks for joining. So let's do this. First thing first, I'm gonna make geometry node. Wouldn't just scaling down rest length attribute work? For the angle value, it's not just a scaling down because it has the direction. You see that if you look at each angle, this is the axis for this triangle, the pair of triangles. And if the constraint rest length is equal to 0, then it doesn't do anything. It's just a flat plane. But then if you set it as 90 degrees for this pair, it would just fold. This pair of triangle will try to fold 90 degrees. But then what if you have something like this piece where you want to set your axis for the rotation, but this axis is not really aligned with the triangle's edge, the pair of triangles edge. Then those cases, even if you want to like bend like 30 degrees for within using this axis, you cannot just use the 30 degrees as it is for each pair of triangles because the direction is different. Okay, it's not really straightforward. So you need to do some calculations, mathematical or geometrical calculations, in order to achieve the right angle for each triangle, the pair of triangles, based on the axis. Okay, and the equation itself is pretty simple. You just need to do a little bit of vector-wise calculations, and that's all you need to do. So the setup itself should be really simple to achieve. Okay, so let's do this. I'm gonna start by creating a grid. I'm gonna make rows and columns to 2, and I'm also going to create going to remesh the geometry, and I'm gonna test this with different resolutions later. So let's also have a null node to have all the parameters that I can control later. Okay, and let's give a parameter. The first parameter for this setup is the resolutions for the grid. Where is it? Okay, so I'm going to just drag and drop the target size for this remesh. Gonna call this res. Okay, so this is the first parameter so that we can control from here. All right, next I'm going to create a input curve in order to achieve the bending. But before using the input curve, I'm going to show you the basic principle of the calculations so that you will understand you'll better understand what I'm going to do next using the curve. So the things that I'm going to do now is to set any arbitrary vector value, which could be a x directional vector or z directional vector. Any direction is fine, but I'm just gonna use any vector as a sample to show you the basic principles of this bending. Okay, so I'm going to just set the I'll just use the attribute create to create a detail attribute called deal. For detail, make it vector value, and let's make this 1 0 1, or let's start with 1. So x directional vector, which in this direction. So what I want to do now is to use this direction to bend this plane using a Vellum constraints, bending constraints. Okay, so let's try to do that. I am going to convert this into a cloth constraints, which includes a stretch and the bending. So Vellum cloth, yeah, this one. And because I want to test the bending, I want to make the stiffness of the bend to really high value so that it's easier to see the effect, so that it looks like a rubber like material. Okay, and for the stretch that's fine. Okay, and everything else I'll just gonna keep it as default value. Let me also save this to today's folder. Okay. Okay, now let's check what we have on the constraint, which is from the second output of this Vellum cloth constraint node. So if you look at the second output, these are the constraints, and it includes both stretch and the bending constraints. If you look at the geometry spreadsheet primitive tab, you could see there are two types of constraints, and what you want to deal with is this bending, okay, not the stretch. So for now, just to see how it looks like for the bending, let's just try to get rid of the stretch and just see the bending. I'll just get rid of this delete later, but just to check how the bending constraints look like. Okay, so this looks like a star-like curve. Doesn't really look straightforward to me, so I'm just gonna try to pick one of the constraints and see how it really looks like. So I'm just gonna pick one of the polyline from this bending constraints, try to see how it looks like. And where'd it go? Okay, so it looks like this. So what does this mean? If you show up the original mesh, the curve, which has 4 points, is laid on top of two triangles. Okay, so this constraint indicates that it will be used for two triangles, the pair of two triangles. And using the rest lengths of this constraints, you can control the angle between these two triangles. Okay, so let's check the geometry spreadsheet and see how it looks like. So right now the rest length is equal to 0, so it's going to be a flat plane. Now if you change this value to something else, then it will try to use that value to bend it, pair of triangles. So let's see if I just change this rest length to some constant value like 30 degrees and see what happens. I'm gonna use the primitive wrangle from constraint node. Just filter it with the bend group. Okay, doesn't really have a bend group, does it? Okay, have to connect with the second output. Filter with the bend. And let's try to change the rest lengths to 30 degrees and see what happens with Vellum solver. Okay. Gonna connect the original geometry to the first and the constraints to the second and the third to the third. Okay, and also I am going to disable the collision for now, as well as gravity, so that I can do a quick simulation test. Okay, so let's see what happens. So every triangle, every pair of triangles have a constraint, and I have just set the rest length, which is going to be used as the rest constraint angle, to be 30. So let's see what happens if I play it. Doesn't really look good, does it? If I set this to 5 degrees, something like this. Doesn't really have any direction in terms of the angle. It just it does seem to have some directions. It does seem to rotate using a z-axis or something. But basically it doesn't really relate it to any direction of each angle. So if you set this to 5 or any constant value, will just give you some random bending result. For example, if you change the mesh to something more oriented, mesh oriented, like this one. So, and I'm going to use the divide node to create the triangles, which, as you can see, there seems to be some direction, some directions to this triangles. You have tons of edges on this direction, diagonal direction. By having this, I am assuming that the folding will come something around here, something like this. Let's see what happens. That's my guess. Yeah. Not that so obvious, but you do see some different result from the previous one. So that's a bit of problem. I mean, it's not a big problem because it's not really intended to use it like this, but what I want to do is to control this rest length precisely so that you can bend in any shape as you want using a vector field or using a input vector. Okay, so that's what I would like to try out. And the first test that I would like to do is to specify the axis. Could be on the XD plane, and it could be in any direction. And based on that direction, I want to bend the geometry using that as an axis. Okay, so let's try to think how we can do that. So let's draw some sketch. Okay, so I think it's only being bent towards central. I see. All right, so let's see if you have a mesh. Maybe I should make it triangulated more randomly, remeshed stuff. And you also have a axis. And what you want to do is to use these two informations. You want to bend this surface based on this axis information. If you have a vector value, something in this direction, then you want to bend the geometry like Really bad at drawing. Something like that, I guess. So this point and this point will be folded, or correspond to this point and this point. Okay, so that's what I would like to see. So in order to do this, what I think it would work is to first pick each triangle pairs, like these ones, which have a random direction in terms of these edges. Okay, and for each pairs of triangles you have to set the right angle. But you already have your axis, and what you want to do is to rotate in this direction. So comparing with these triangles and these axes, you can obviously see that the axis direction is different, so you need to have some kind of information in order to let's say you want to rotate theta. So you need to know some way to convert this theta for each triangles by looking at the difference between this direction and each pair of triangles edge direction. Okay, and what I'm gonna use is the basic dot product as well as the lengths of the edges. Using those two informations, you'll be able to actually map this angle theta to each of the corresponding edges angle. Okay, the idea is if you have a triangle like this, let's say if you have a in between edge like these, and you have an axis which you want to rotate for. First, what you want to do is to first project this edge direction, either this way or this way, to this axis. By projection means I want to get the length of the projected vector value. So you can use dot product for that. By using dot product between B1 and axis, or let's call this VA and VE, and dot product of this VA and VE, and I want to make sure that the VA is the normalized vector. What was the notation for the normalized vector? Forgot. Like that? Maybe? No, maybe not. So, well, I want to make sure that this is normalized. And for VE, you don't really need to normalize because the length of the edge matters here. So I'm going to keep it as it is. And by using dot product between these two vectors, you'll be able to get a length of projected a length of this edge projected on this vector. Okay, let's call this H. Okay, now if you also normalize VE temporarily, what you get as a result for this H value is in between 1 and -1. If the direction is equal to this axis, meaning it's straight forward to the same direction, you get either 1, you get 1. if it's the opposite direction, then you get -1. So by calculating absolute of h, you'll get a value how much it aligns with, how much this vector value aligns with this blue axis vector value. Okay. So you could kind of call this as a ratio of the closeness. Okay, and by multiplying this h by the length of this VE, you'll have a weighted ratio. Okay. And I want to use this value to map the value theta to the corresponding angle for this triangle mesh. So if it's equal to 1, if the h is equal to 1, the absolute of h is equal to 1, then the angle is obviously equal to theta, okay, because it's on the same edge. If it's on 90 degrees, then you don't really want to rotate this edge, because if it's aligned with this edge, the angle for these triangle should be equal to 0. So that is also that information can also be retrieved from the dot product as well, because the 90 degrees dot product is 0. Okay, so start to make sense. And so you can actually use this dot product as a ratio of this theta. So let's call this dot and let's say the dot product based value is in between 0 to 1, and by using this dot product you could actually calculate the angle of this vector E by multiplying theta by dot. Okay. And later you could also use this length of the vector as a weight to compare with other edges. Each edge has different edge lengths, so multiply with the length of edge and then divide by the maximum of the length of the edges. Will give you an average or a weighted value of the angle by considering all the edge lengths. Okay, so that's what I would like to do here. Maybe I should call this theta A or something, or theta E. Yeah. Okay, the idea is simple and it's really easy to implement, and it works. Okay, so let's see how I'm going to actually implement this thing. So I'm going to use a primitive wrangle, and in order to do the implementation, you actually need to have the triangle pair informations for each edges. So first we need to know for each constraints, like we have here, we need to know which constraint belongs to which pairs of triangles on a mesh. So first we gotta make these pairing information. Okay, so and because the pair of triangles are always having the in-between edges, what I'm going to do as an approach, I mean there should be a many approach to deal with this one, but what I'm going to do is to first convert the original mesh 2 lines. And I'm gonna look for each edge and search if there's any neighbor polygon or neighbor triangles for each edge. And if there is, you get one pair. And using those pair informations, I'm gonna make a connection between each constraint from the Vellum and a pair of triangles. Okay, so first thing first, let's create the pairing informations from each edges. All right, so how do we do that? First, I am going to make the group for each edges, just in case I might use it later. I'm gonna name this edge. Not really straightforward, but edge. Okay, and I'm going to use the primitive wrangle. So what I want to do for each edge is to find a corresponding primitive, which is from here. Okay, the first input, first output of this Vellum clove. So going to connect this to the second input as an information, and we're gonna try to get the primitive number, 2 primitive numbers for each edge. So this edge should include the primitive number. In this case, it's a bit small to see. In this case, 3602 and 49479. So let's see if we could do that. All right, so the good thing about convert line is that it preserves the point number, so we can use the point number to search for the corresponding triangles which have those edge informations. So first, let's get the point list for each edges, and since it is edge or a line, you only have 2 points for each primitive. So prim points. And let's get 2 points. Now, using these point numbers, you could actually create a half edge information by using point edge. And what I want to refer to is the second input, which is the original mesh. So I'm going to try to find the half edge information from the second input using PT1 and PT2. Okay, and let's call this edge 1, and you could have the half edge belongs to one of the triangles. If you are looking at this edge, and if I have just created the half edge in between these points, point 1 and point 2, this will be either this triangle or this triangle. I don't know which one is gonna be, but maybe this one or maybe this one. Now, so it only gives you one primitive information from one half edge, but since there are 2 half edges on this edge, one for this primitive and one for this primitive, you can actually get the equivalent half edge by using edge next equiv. By using this one, you could get the other side of the half edge. And by using this. Okay, now, or maybe a better way is to use point edge and start from PT2 and PT1. The reason why I don't want to use the half edge next equivalent is because there is a chance that I would pick a half edge that doesn't have any triangle. Okay, so in the border situations, there's only one triangles for one edge. So one of the half edge will be equal to -1, meaning you couldn't find any half edge for these positions. So for if it becomes -1, then you cannot find any equivalent. So I think this is a bit safer to check each half edge. And I want to make sure in order to have the pair, both value has to be equal or more than 0. So you have to create the conditions if half edge 1 is equal to 0 or larger than 0, and half edge 2 is equal or more than 0, then that's when you could actually get the pair of triangles. So primitive 1, one of the triangles name or point, the primitive number is, you can get the primitive number by using hedge prim. This is for the hedge 1, prim 2, hedge prim 0, hedge 2. Okay, so let's see. We're going to create an attribute called prim1 and check whether this seems correct or not for each edges. All right, so let's show up the primitive number for each edge. For example, if you are looking at 773, which only has one edge, in those cases that's an else condition. For those conditions, I'm going to set the primitive to number -1. Wow, Jason Mantran, thanks for the super chat. That's a lot of money. It helps me a lot with works at transportation field, but I often use Houdini. Any chance you will do a tutorial on using GIS data like OpenStreetMap for creating a system? I actually did use OpenStreetMap data for one of the projects I did previously. So of course I could show you some essentials how the OpenStreetMap data could be used on Houdini, but I believe there is a plugin or Houdini Labs job node in order to use the OpenStreetMap data. I think forgot how is it called, OSM. Yeah, like this one, Labs OSM building, Labs OSM filter, Labs OSM import. This will be the starting point, I guess, to do the OpenStreetMap data. But surely, if you're interested, I could try using that as an example. Okay, what was I? So I have just created a primitive number for each edges, and if you're at the border, the two primitive numbers should be equal to -1. So let's check. Gonna open up the geometry spreadsheet and check for a edge number 773, which is this one. And if you look at the primitive, 773 for primitive attributes. Okay, so you can see that both prim1 and prim2 is -1. So what about 774, which should have two primitive or true triangles? And 774, okay, it also says -1, so something is wrong. And I think I need to change this. I forgot to change the network input number. Okay, let's check this again. So 773 negative 1's fine. 774. So you have number 1000 and 1299. And let's go back to the original geometry and see if the number is correct. 1299 and 1300. Okay, so it looks correct. So pretty much the pairing is I have already got the primitive pairs. You just need to use the right information so that it'll be easier for each constraints to search for each point for each pairs. So what I'm gonna do is to get all 4 points using these triangles, because that's also the points for the constraints, and get the average of those 4 points and try to set it as a position attribute to each edges, and so that we can use it to search. We can use that to search from the constraints to these pairs. So let's try to get all those 4 point destination information. So what we could do is to just calculating or just get the next half edge for each half edge 1 and half edge 2, because if the half edge 1 is coming from this point to this point, then the next half edge for this half edge is going to be this point to this point. And by getting the destination point of the next half edge, you'll get these points, and you already have the point information for this edge, this point and this point. So do the same for the half edge 2 to get the tip of this triangles, then you get 4 points. So oh, hello Hex, thank you for the super chat. I just got 490 for Houdini, 4090. Yes, I did too. I'm currently using for Redshift, also for Unreal engines a little bit, and some gaming, of course. Works pretty fine, looks pretty well. And where was I? Can you tell me how it performs? In terms of the GPU rendering, it works perfect. I mean, I'm using Redshift to do the renderings, and it's really fast. It's really fast using GPU-based renderings. And yeah, that's what I really love about it. So for the production usage, currently that's the only use case for me. Other than that, just using for path tracing renderings for Unity and Unreal, and also for gaming, we're using ray tracing. How about OpenCL? I haven't tried OpenCL myself, so I haven't checked how it's gonna affect it. Maybe it's gonna work very fine. What was I? So tip point, yeah. So let's calculate the next half edge for the edge 1. Also the next half edge for the edge 2. Again, you need to look for the second input. Right. Then you could get the destination point for each next edge by using edge destination point. edge destination point. Oh, again, always forgot. All right, now you have 4 points, PT1, PT2, and PT1, and PT2 corresponds to these 4 points. Now I am going to append this into an array. And use this to calculate the average point position. So I'm gonna loop through all the points. Not really smart, but let's just make it simple. Get the point position. You could either get from this first input or second input because you're sharing the same point position. But I'll just gonna get from the second. Then let's also create the average point position. Then add each points, and in the last I'm gonna divide it by 4 so that you get an average or the length of the array. Either way is fine. Alright, so that is going to be the average point position by getting all 4 points and just getting the average. And the point position of the primitive, I mean the centroid of this primitive also is calculated as an average of 4 points for each constraints, actually, which I have tested. So you could actually use those 2 informations to find the pair. So mistake. So now that I got this average point position, let's have this as a attribute. Like that. Okay. And for this one, I'm gonna set it as 0. Okay. Now, what else do I need? I guess that's all the information I need, I think. So in order to find the pair, which using these attributes from each constraints, there are several ways, but the fastest way that I could think of in terms of the efficiency, I would use a fx functions called a PC find. PC find. PC find can look for a point attributes corresponds to by using as a distance, using a distance metric, Euler distance metric. So if it is a vector value, you could actually calculate the distance between one position to another position. Even if it's not a p attribute, it could also even be any attribute, but as long as it's vector value, you could actually calculate the distance and get the closest one using this one. So this is pretty useful. And so this is what I'm gonna use. All right. So in order to do that, you need to have a point instead of primitive. And right now I only have edges. So what I'm going to do next is to convert this edge to point and use only those points, newly created those points, to get an information. Okay, so I'm going to create a new point. And probably at the average point position. might make sense. So I'm going to use average point position. All right. And also, let's also set an attribute to this newly created point, which have the information of each triangles. Prim1 and prim2. As well as the vector value for this axis, including the lengths of these edges. So that can be done by getting the point position of these 2 points. So let's also get those 2 point position. And I am going to set the attribute. Let's just call this direction. And I'm just going to subtract position 2 by position 1. It could also be position 1 minus position 2. If it's it doesn't really matter if it's at the opposite direction or not, because we're just going to calculate the ratio as an absolute value. So either direction is fine. Okay. It's getting cold. Let me turn on my AC. Might going to sound a little bit. Okay, what was I? So now that I have directions, what else do I need? That's probably it, I guess. Now in the end, I'm going to also set the group, set point group. How do I call this? Edge point. Okay. I'm gonna call this triangle pairs. Alright, so now you're going to get those points, and for each point, what you're gonna get is the point positioned and the directional vector value, these ones, as well as the primitive 1 and primitive 2. Yeah. Okay. So that's, I think, all we need to get as an information. So let's then use these pair informations together with the constraints. So from each constraints, we're going to search for the corresponding pair information, which is a point in a edge point group. And if we find one, then that's the corresponding pair information. So let's see, how do I name this? Constraint, bend constraint, angle. Okay, so what I'm going to do, so I'm going to try to use this function called PC find. So I'm gonna copy all these. Okay, so first of all, geometry, searching for a second input. Okay, maybe not this one, but I want to set the group, so the second parameter set. So looking at the second input, the PD group is edge point, the point channel. In this case, we could just look at the P. And what we're going to use as a search from information is at P, because the primitive if you use @p on the primitive, you get the average point position of each point. So this will be just fine. And the radius, you should make this small as possible so that you only get one information. Maybe 001 is fine. Integer maximum point number. So I'm gonna set this to 1 so that you only get one value. But anyway, you get it as an array, and want to check if the length of PTS is more than 0. And if it's so, I'm going to set the attribute of each constraint just to check. Let's call this pair and get the first point from the PTS. And if you couldn't find it, if you couldn't find any, then set the pair to -1. Now I have set this else conditions, but since each constraints are coming from the pair of triangles, you should never have this negative value for any constraints, for any bending constraints. So if you have any -1, then that means you have some problem with your implementation. So let's see, geometry spreadsheet, primitive, and I want to just check the bending. So temporarily I'm just going to pick the bend constraints. And look at the attribute called pair. Okay, so everything is positive and no negative value, no -1, so meaning I think I have successfully found the corresponding pair information from the second input. Alright, it's good. Now, after having this information, you entered an edge instead of hedge. Is it? Is there any delay? Because that was a while back ago. Maybe I fixed it, I'm not sure. Yeah, maybe I fixed it. Maybe there's a delay on the live stream. Okay, so where was I? So having these information, now I can get all the necessary informations like triangle information, triangle numbers, and the edge triangle numbers, and what was it? The direction. Okay, so let's try to get that. Line 17. Line 17. Maybe I fixed it. Maybe. I think it's working, so probably. How did you prompt it, the find option? Sorry if this sounds like a very basic question. How did you prompt it, the find option? You mean on the vex? You could use, oops, wait. You could use Control F or Command F on search for. Is that's what you're asking? Prompted the find option. Or this one, PC find. Okay. Okay. So, well, this is just a function, so you could check how you can use this. here. Now, where was I? So what I needed to do is to get the directional information from each point, and direction PTS 0. There's also a primitive 1. Primitive 2. Now, actually you only need to have a directional vector in order to calculate the correct angle, so maybe the primitive number is not really necessary, but just in case you want to use it for other purpose, gonna get it. Okay, now now let's check the direction, see if every constraints have the direction. Now what's wrong with you? Unexpected equal expecting 29 with syntax error unexpected equal expecting identify one interesting. Okay, something must be wrong. Is this one? Seems this at. Okay. Still. Syntax error unexpected else. Unexpected else. Really? If I remove this, okay. Else. I should be able to use else, right? Nope. Okay. Interesting. Why is that? Seems like... Oh, there's a hidden word somewhere here. I'm not sure why. Maybe I'm using... it's a bug, or maybe because I'm using a Japanese keyboard or something. Okay, now it's okay. So pair is -1. B direction, maybe I could just set it as 0. And prim1, prim2, prim2, prim1, -1. Now this should not be called, but just in case we see to debug. If we see these, then that's a problem. Okay, again. Why am I having preload shader is invalid? Vex error, preload shader is okay, that's new. Not sure what's really happening here. Oh wait, what's this? Where did it come from? Something really interesting is happening here. I'm just gonna copy this and repaste it to a new one, because it seems like there's some hidden code which blocking me with an error. Oh, nope. Oh, stupid mistake. Okay, so that's okay now, hopefully. Okay. Sorry for all those hassles, and let's see the bend constraints again. See if we have direction for each constraints. Yep, there it is. Okay, now we are finally ready to calculate the angle using these equations that I explained. Okay, so first we're going to calculate a dot product between the axis and the direction of each edges from the pairs. So I'm gonna just do it right here, and since we don't have an axis information yet, let's get that, and that should be on the detail. Yeah, so I'm gonna get this as a base information. Gonna get it from the detail, axis, no, direction, that, and I'm going to calculate the dot product between the axis and this directional vector value. So dot between the axis and direction which will give you a projected length for the vector direction on top of the axis, okay? Which also include the length of the vector value, since this is not normalized. Alright, now since I want to calculate the weight, I want to use those lengths as the weight. In order to do that, you want to divide the total length of this vector value by a maximum edge length for whole edges you find here, so that each one will share a length, the ratio between 0 to 1. If it's close to the maximum edge, you'll get the value equal to 1. If the edge size is the half of the maximum size, you get the ratio of 0.5, and that value is going to be used as the weight. So I'm just going to promote the rest length of this convert line as maximum value. From primitive to detail, get the left lengths, get the maximum, change new name, max rest lengths. Okay. Let's check. Going to detail. So this is the maximum length of the edge, and each edge will have a value between 0 to 0.2989 or something. And if you divide the length, each edge length, by this maximum, the value will be each edge will have a value in between 0 to 1. And that value is going to be used as the weight. Okay, so let's get that from the detail. Not here, but here. So that information is coming from the second input, I think. Yeah. Let's get an information. Float. Max len detail. Second input, max lest lengths. Okay. And I want to use this to divide the direction vector value when we calculate the dot product. Or we could do this later as well. I mean, after we could do this like this as well, but either way is fine. But I'm just gonna do it on the vector value so that we can pack it on one line. Now now we have a dot product. This might going to be positive or negative based on the orientation of the vector value, so I'm going to just need the absolute value of the dot product as the ratio, so I'm going to get the absolute value. And finally, this absolute value can be used to change or map the angle that we actually want to use to for each pair of triangles. So let's also give a parameter for the angle. So for, let's say I want to, where is it? Let's make this angle ratio in between 0 to, could also be negative, so maybe 180 to 180, negative 180 to positive 180. Okay, like that. And maybe that's too much. Let's make this minus 90 to positive 90 degrees. Okay, and now so this is the actual angle that I want to use to bend the whole thing using this axis. So in this case, the x-axis is here, and so based on this axis, I want to bend with this angle. And the angle for pretty much for each triangle piece, if the triangle piece is aligned with this axis. If it is not aligned, then the angle should be smaller. And in order to make it smaller, you could multiply the final angle multiplied by d as a ratio. If d is equal to 1, then you get, if d equals to 1, meaning it is aligned with the axis, you don't really need to make the original angle smaller. But if it's the d is smaller than 1, if the direction is not aligned with the axis, d will be smaller in between 0 to 1 and make the angle shorter, smaller, like that. And finally, we could use that as the rest lengths. And let's see. So that should be it. And if you couldn't find any pairs, I'll just set the last lengths to 0. So let's see what happens. So I have just modified the rest lengths. Wait, I don't see it. Oh yeah, here. Rest lengths for the bending. Yeah, okay, spell mistake again, I assume. Why do I have 2 rest lengths? Rest length. Okay, legend. Where did it come from? Did I? Okay. Okay, so should be fine. So that's like the maximum is 17, which should be close to this one. Yeah. If it's equal to 19, then meaning that the axis is along, the edge is along the axis. So it should always be smaller than the one that you set as a parameter. Okay, now everything is set. We are ready to test. So x-axis is horizontal direction. So what I would like to see is to bend this bend this plane like this arc on this edge. So let's see. Yeah, maybe too much angle, but it is rotating on the direction that I want. Let's make the angle to 5. Okay, looks good. Okay, so it's time to check if this still works by changing the direction, the axis direction. So right now the axis is in the x direction. If I change this to something like diagonal, now this is no longer normalized, so we should normalize it somewhere. Yeah, maybe we could normalize it here. So right now the axis vector become 1, 0, 1. In this case, x direction is this way and the z direction is this way, so probably these axes, is it? It's a bit too small to see here. Maybe this direction and this direction, so maybe these axes, these diagonal axes. Let's see what happens. Okay. Right. So I think it is working. Yeah. So based on the axis, you could now control the bending even if the edge direction is not really aligned with the axis, using those ratio calculation. Let's test this again on making like 3 by 1. Great. Yep. Just like Norimaki. Isn't it? Okay. So that's good. The base has been calculated well. So we're gonna use this base calculation to use it with more specific controls over the bending. For example, using curve as a input information and using just bend where it is close to those curve with specific angle, and using the curve tangent vector as a vector axis for the bending. Okay, hopefully makes sense. So I'm gonna keep this basic implementation as it is and just copy bend and name this with bend width curve. As always, I'm going to share the file after the live stream so you can look at the file to see for yourself and play for yourself. Hopefully you find it interesting. Now let's try to create a curve informations to bend. I'm gonna start with the really simple one. I'm gonna start with the line then. And later I'm going to change this to a bit more like more complex curve. I'm going to make this 1, 0, 1 as a direction, or maybe I'll just gonna draw the curve by myself. That'll be easier. So I'm going to use a curve polygon and just draw some curve. Maybe I could draw multiple curve to see if we could deal with multiple number of input. Okay, and where did it go? Yeah, this one. Now for the testing, for the initial test, I'm going to try with one curve, and later I'm gonna try with the multiple number of curves. So for now, let's just pick one because it's easy to debug. Right, connect this to a third input. Now there should be several informations we need to get from these curve. One is the tangent vector informations, and there is a chance that this is going to be like curved, like circle or an arc or a spiral or anything. So in those cases we are going to have multiple number of points, so we're just going to resemble that by using resample node, so that we could have multiple number of points. And for each point I'm going to calculate the tangent vector value, maybe as well as curve u. I'm not sure if I need this, but just in case. And what else? Probably that's it. So, so we have tangent and the u information, the curve u information, which going from 0 to 1 from the start points to the end point of the curve, which might be useful later. Now, having that information, let's try to modify the constraints and use those curve to retrieve the vector information as an axis, and also the closeness to the curve from each constraint. Okay, so where should we? So first thing first, what we're going to do is to replace this constant direction with the value from the curve. Okay, so in order to do that, we're going to first project each constraints to a curve and search for the closest point on a curve for each constraint, and then from that constraint, from that position of the curve, we'll get the tangent vector and use it as an axis. Okay, and we're also going to calculate the distance. Okay, let me show you what I'm gonna try to do. So say you have a mesh, you have a curve, and each pair has the constraints like that. And what I would like to do is to project probably the center of the constraints to the curve. I should change the color. And get the corresponding tangent vector on the projected points and use those tangent as an axis. Okay, you could also calculate the distance, the projected distance, and use it as an effectiveness or effectivity, or the how it will affect the bending. Maybe you could use it as a amount of angle to be used for the bending. Okay, so let's try that out, shall we? So what we need to do is to first project the center point of each constraint to the curve. So I'm going to use the function called xyz dist, which you could also get the UV value on a curve, so pretty handy to get a multiple number of attributes at that point position. And you could also get the distance as well. So from the third input, I am going to use the point position of the constraints. And actually, yeah, no, that's fine. I'm just gonna do it here. And prim UV, that's the output parameter. Now, by using primitive and UV, you could get the tangent And I'm not actually going to name this as an axis so that we could replace with this one. Using prim UV, third input, tangent U at prim UV. Okay, so you could sample the value on the curve. Now that we have an axis, we could remove this. Now let's see what happens. What I'm just doing is getting the vector value from the curve and use it as an axis information here. Now let's connect this. Let's go use a switch node so that we can switch between the curve-based one and the current constant axis version. Alright, let's see. So it's bending like this, and if we look at the curve, yeah, so this is the axis and looks like it is bending with this direction as an axis. So if I change the curve direction or to something else, to something different, like if I move this point to something like that, it should also change the tangent vector value and would also change the how it's going to bend like that. Yeah, that's straightforward. Now it is not taking care of the distance information yet, so let's also implement that as well. Declaration of variable d shadows the previous. Okay, maybe there's a duplicated attribute, variable, so I'm gonna name this dist. Okay, so where is the curve? I'm going to delete this. So what I would like to try now is to calculate the distance between constraints and the curve, and if the distance is close enough, we'll have a bending effect. And if it's a bit too far, then we're going to ignore the bending. So that's pretty easy to do. What you just need to do is to check and I'm gonna use it for a angle probably. Yeah, so let's create a map function. An angle is calculated right here, right? As a constant value. So I'm going to remap this distance to an angle using minimum maximum distance to a minimum maximum angle. Makes sense? So, or maybe the angle, in terms of the angle, the minimum could always be 0. So what I just need is a fit function to remap the distance between minimum distance to maximum distance. Does it make sense? Maybe I'll just need to set the maximum distance. So the 0 will always be the smallest, so maybe 0 is fine as a minimum. And the maximum distance, and change this to 0 to an angle, or if it's close to 0, use the angle, and if it's close to the maximum distance, maybe set the angle to 0. Maybe this might make more sense. Okay, now so this distance is going to be used to check how much the distance will be affected by the bending. So if I set it to 1, somewhere around here, since this is 1 as a grid distance, somewhere around here will be affected as use it as a bending. Okay, let's check that out. So anything else we need to change? Maybe not. Let's see. Slowly. So not so obvious because the angle is pretty small and the area for the bending is also pretty small, so don't really see a much of effect, but you do see a small bending has occurred on these areas. If we increase the maximum angle, maybe 30 degrees, well, now we start to see a more effect. And you could see that based on the distance, in this case 1, the bending only occurs to these areas where the curve was placed. Okay, so if you increase the distance, you'll also increase the affected distance, and the angle will be incremented for each edges. So if you have more affected area, maybe you want to lower the angle. Alright, so works fine, works great. Now what if we have multiple number of curves? Let's say if we have like these crossed curve. Does this still work? Let's check. Then I'm set the maximum distance to 1 and go to 20. Let's see what happens. Okay, well, it does seem to work at some point. Yeah. The thing with this setup is that there's going to be a bit of problem with the current setup in order to use it for a multiple number of curves, because using XYD distance only give you one result, and if the constraint is closed at the center, closed at the cross point position, it will get either one of the curve on the cross, either this one or this one. You don't really know which one's going to be picked, and based on the curves that's being picked, the angle will be different angle will be used because the axis is different. So that's a bit problematic. It's going to, I could assume that some jaggy things gonna happen on these cross sections. So what I would like to have is to calculate the angle for every curves, not just one, but not just the closest curve, but every curve, and if the distance is close enough, do the angle calculation. That's what I would like to do. So we need to update this a little bit, so let's do that. So I'm going to name this as single curve, so which only works for single curve, but for the multiple curve we need to do something else. Can you in the future make a tutorial on how to implement ChatGPT inside Houdini? I've seen some people do it. They type what they want to do in GPT, lays the nodes automatically. Ah, it's interesting. Lays the node automatically. I did try using ChatGPT to try implementing the Navier-Stokes equations to do the 2D fluid simulations. but I just go back and forth on the website and the Houdini wrangle to write the text. But I didn't know you could directly lay the node automatically. That's really something. I don't know if you might need to access the ChatGPT API, maybe. I did I did ask for the wait list. I did register for the wait list. I haven't got it yet. So if I got an API access, maybe I should give that a try. That sounds really interesting. What was I? So, multiple curves. So, and this one, single curve also needs to have a resample. Yep. Okay, so for the multiple number of curves, we're going to do a for loop because we're going to have multiple number of curves. So if we have two primitives from this third input, we're just going to loop through all the curves. And where should we set that? I'm just going to start from beginning. And what I want to do is to increment the final angle value, which is this one, and use that as a final angle for each constraints. Okay, and since each curve will provide you with a different tangent vector, I think I need to just loop the whole thing like that. Okay, and let's see where I need to fix. I just want to thank you for a tutorial. I'm just starting to understand Vex. Well, thank you for saying it. I really appreciate your comments. Okay, so what was I? So we have a loop. Oops. And for each curve, we want to calculate. Seems like the website, the YouTube is reloading a lot. Maybe there's some problem with the streaming. Maybe. Hopefully things get fixed. Anyway, I'll just hopefully it will be okay on the archive. Now, what was I? So I have I here. So for each primitive, we want to recalculate the distance here. So let's check the function. If we could specify the primitive number for the XYZ distance. And yeah, we could actually use a primitive group as a second input. So we're gonna convert the primitive number to string and then use it as a group filter so that we could search the distance, we could calculate distance to a specific primitive number like this. Okay, and rest of the stuff could be just okay, I think. This one is also okay. Now in terms of the direction, that's what we need to change here. No, I mean the tangent vector value. Oh, although the primitive is coming from this result, so that's also okay. So I guess that's the only things that I need to change. Now what I need to do actually is to increment this rest length for each for loop, and then get the final value as the final result that we're going to use for the pairs angle. Okay, so I'm gonna name this final angle. And I'm going to increment this value here. To the final angle. And then after leaving the loop, I'm going to update the angle with the final angle. Now I also probably need to do the average if one point finds two curve to calculate the distance, to calculate the angle. So in those cases, I think I need to do some average calculations somewhere. I cannot just divide it by the number of primitives here, because there's a chance that one point only belongs to one curve. The average needs to be done when one point belongs to two curve. Okay. So that's what I need to do, and probably I also need to wait based on the distance, how close it is to each curve as well. So that's a bit tricky. Let's think about the weight first. So the weight is actually get it from here. If it's equal to 0, if the distance is equal to 0, then the weight could be equal to 1. If it's equal to maximum distance, equal or more than maximum distance, then the weight could be equal to 0. So let's give another variable called weight and fit distance from 0 to CHF maximum distance, and if it's equal to 0, make it 1. If it's equal to or more than maximum distance, 0. Okay, and multiply this weight but it is actually already being used. This information is already being used and as an angle here, actually right here. So maybe it doesn't really need to be multiplied here. Maybe it's just fine just adding all those angles all together because the distance to the curve is already being taken care of with these angles, so maybe it's fine. Let's just see the result. Okay, so now that we have multiple number of curves, let's connect it to the switch. See what happens. Okay, seems to work fine. Now let's try to change some threshold or distance, maximum distance, to see a bit more harder edges, like 0.05, and see what happens. Maybe that's too small, I'm not sure. Let's see. Yeah, that might be too short. If the constraints is smaller than I mean, if the maximum distance is smaller than the distance between the constraints, then this will do nothing. So have to be big enough so that it's a little bit bigger than the size of the mesh, the length of the mesh or edge. Okay, so it does seem to work. It is using, maybe I could increase some angle here to 60 degrees. Okay, and looks pretty good. And once again, the benefit of this setup is that you don't really need to remesh your original mesh with a curve or anything. You can just use the original mesh as it is and just change the bending rest lengths, and that's all you need to do. Now it doesn't give you a really hard edge like the folding, but there should be some use case for this one, I think. And looks nice. Okay, so let's try to change this to a more curved curve. I mean, like a spiral or circle or something more complex. So I'm gonna try with the spiral first. And change the size of the spiral to lay on top of this plane. Okay, this one. So how's this? Okay, and maybe we could have multiple number of spirals. Like rotate this 180 degrees using y-axis. Merge these two. Making more like an yin-yang pattern. Okay, maybe there's a bit too much turns. Let me try to decrease the turns. Where can I do that? This one. Okay, and also increase the radius. Okay. Where is it? Here. Okay. Like that. And see what happens. Hopefully we'll just go with the setup. Okay, yeah. I think I do see some ridges. Maybe I could, in order to see a bit more effect, I could set the resolutions to something smaller. Like that. And checked it. There you go. Nice. You could also have some information on a curve to use it for mountain folding or mountain bending or valley bending based on the curve information. If you want. I mean, anything is possible now based on any kinds of attributes, so it's really up to you how you want to use it. But let's say if I have two curve, and let's say one of the curve want to bend on the mountain side, one of the curve bend on the valley side, specify by the group maybe. So I'm gonna create a primitive group, one with the mountain, one with the valley. And based on those group information, maybe we could flip the angle to negative. Okay, so we could do that by checking the primitive information here after calculating the distance. So we could say if in prim group 0 2 mountain for this prim is equal to 1, then let's create a scale integer value equal to 1, and if it's equal to mountain, then keep the scale to 1. Else, if in prim group valley prim is equal to 1, then set the scale to -1. And what I want to do is to multiply this scale to an angle to flip the direction of the bending. Now let's see what happens. There you go. One of the curves being used as the mountain side, one of the curve is being used as the valley side, and all works great. And you could also have more smoothness on the edge if you want by increasing the distance threshold. In this case, you also might want to reduce the angle. Okay, so it doesn't really look like origami, but more like a bending for the cloth object, but interesting enough. If you want to have more like origami folding, then maybe you want to look at this one. Freeform curve folding, which is also on YouTube. Okay, so that's pretty much it for today. Let me know if you have any comments, feedback, suggestions, anything for this setup. If you have any ideas, how could this be used, in what way this could be used, or how this could be improved, or anything is welcome. And let me know how you think about the method itself, if it is new to you, if it is simple, if it was a bit too difficult to understand or anything. Okay, but hopefully overall you liked it. At least I have enjoyed creating this. I mean, I wasn't intended to create this setup. I was making something else, but this method just came to me, and I thought this would give a try to do the simulations, and it just worked fine, so just wanted to share with you guys. Yeah. Hopefully you liked it. Let me just organize the parameters and I will end the live stream. Let's also check with these triangles and see if these are going to work as well. conceptually it should work in any situations, but there might be some glitches here. So let's see how it's gonna look like with these triangles where the diagonal curve is really strong here. If we could still simulate similarly, and there you go. Yes, you could. Yeah, I think I like it. So it could work for any mesh. It could even work for a 3D mesh, just tweaking a little bit. Right now I have worked on the 2D mesh grid geometry, but doesn't really limit it to 2D. It could work, it could surely work for 3D as well. Right. So yeah, it's good to know. So let me organize some parameters. You should do a Redshift session one day. Redshift, well, I could, but I think I'm going to disappoint a lot of people because my rendering skill is really bad compared to a modeling. So I could, but you must promise me not to laugh. Okay. All right. Okay. So where was it? So let's have this as a parameter. The constant vector value. So and we also want to have a switch. We also have a switch between the types. So I'm going to use the ordered menu. I'm gonna just name this type. Going to the menu. So the first one is, what was it? Constant axis. Second one, single curve. Third one, multiple curves. Okay. And there is a parameter for the constant axis. Where is the vector value? Here. Constant axis. I think I could hide it based on the information of this type. I forgot how to use this. I'll just ignore it for now. Just want to see how you can bring different attributes into Redshift and blend them and stuff. Would be amazing. Okay, that I can do for sure. Hi Jason Mantran. Thank you for the super chat. You explained very well. Thanks for the workflow. Hopefully you will show more exciting projects. Also, do Houdini in Unreal Engine 2. I haven't bring Houdini onto Unreal Engine. I'm just using Unreal Engine as it is for now. But yes, I would like to use Houdini engine on Unreal. I am doing it on Unity, but I'm pretty new to Unreal, especially Unreal Engine 5. So yeah, in the future I would love to bring Houdini. What software did you use before Houdini? Well, mostly I was using Rhino and Grasshopper. Yeah, I've been using that a lot on architectural field or product design field. industrial design field, and just found out about Houdini like 5 or 6 years ago, and being fascinated. Soft image. I have never touched soft image. I've never used soft image myself. A little bit of Maya and Cinema 4D, but no soft image at all, actually. Yes, seems like a lot of people come from Maya because it's de facto standard for VFX, I guess. But I haven't touched Maya for a long time, so I'm not sure if I can use it again. Maybe I would just rather choose Cinema 4D if I had to, because that looks easier. What was I? So constraint. There we go. I just start using UE since it is powerful rendering that I need for my work. I see. Yes, the rendering quality of Unreal Engine is so good. I also really want to use it for my project, but my interest, a lot of time my interest just goes to the logic itself, and the rendering part becomes the more of a side effects for me. But I do realize I need to dig into the renderings as well to make the project prettier, for sure. Okay, copy this switch, then paste it here. What else do we have? So we do have curve input. Yeah, well, these one you could just replace it by yourself. I'm going to group it, maybe color it to something easy to see. Unreal is also good at handling geometry because of the night. Yes, I tried the night, and well, it only accepts static mesh, I believe. Doesn't work with the dynamic mesh or precision mesh, but yeah, it is really powerful for sure. Especially for the mesh being scanned out from the real world. Wrestlings. Okay, this doesn't have any parameters, so these are the parameters we need to set. So the angle here. Just drag and drop. Constant angle. And this is for the single curve angle. Or you could just use the same value with the multiple curve. So I'm just gonna use curve angle. curve max distance. And yep. Apply. I'm gonna copy this channel to here. This one to here. And I guess that's about it. That was a small amount of parameters for me. Okay. Anyway. And if I change this to multiple curves, alright, works. Resolution, changing the resolutions, alright. Cool. Changing the threshold to small. And set the angle to really high. There you go. Cool. So, it's pretty generalized, I guess. And thing is that it doesn't really limit it to curve, but the reference could also be surface or any equations or geometrical informations could be used to calculate the bending. The important part for this tutorial here is how you could calculate the rest lengths for the constraints for the Vellum based on the vector. So could also be like a vector field. It just takes a lot of time importing stuff like Alembic. Yeah, I feel it. I feel you. Yes. Also the compiling part. Right. That's a little bit of downside. But still gotta use it. Okay. Anything else? If not, maybe that's about it for today. Thanks for joining on today. This is 27 February already, and actually yesterday was my birthday, so thanks for joining at my birthday live stream. Alright. Okay then, good night everybody, and take care. Have a nice day. I'll try to come up with something else next week, which if I found something interesting. Alright, so that's it. Thank you Jason, and good night everybody. I'll see you next week. Thank you, Dongwon. Oh, forgot to say, as always, I'm going to post the file that I've created today, this one, to a GitHub, and you'll be able to access to it from the video description page of this YouTube live, or you could also get it from the Patreon page for free. Well, if you could support me on Patreon, that would also be awesome, but if you are feeling like it. Hey, thank you very much, and good night.